This is our final term paper as real-time recognition for sign language. And so as we've discussed in like our earlier presentations, sign language is a way through which the people who haven't necessarily been gifted with hearing and speaking abilities can communicate and interact with others, with each other. Yeah, one of the basic forms through which we communicate is by speaking and hearing. So though not everyone is able to speak and to hear. So sign language is therefore a medium through which hearing and speech impaired people communicate. So, but since it would be hard to like teach everyone sign language, this real-time translator is rather essential. So we decided to view deafness as like a cultural identity instead of viewing it as a disability. So just like other cultures, the deaf culture can be identified with that particular unique thing, the way the Americans are identified with their English. The deaf culture can also be identified and distinguished with the sign language. So we are using AI for all this, and AI is basically describing a creation of systems, computer systems, which have the ability to perform tasks that would ordinarily require human intelligence, tasks like thinking, making decisions, because now AI can make decisions depending on the algorithm that has been used to build whatever is being built at that time. So we're using computer vision and machine learning, which are very relevant to sign language identification. So this study, we've been using various approaches to sign language, but the major three are computer vision, machine learning, and deep learning. So computer vision is basically a field that's dealing with how we extract information from images. For example, if I did this, the computer should be able to know to get this image and tell that that's an L. So it has extracted that information from a mere image. Then machine learning is a subfield of AI, artificial intelligence, which basically focuses on how algorithms can be developed. And these algorithms should be able to learn. They should be able to learn. Then the last one is deep learning, which is now a subfield of machine learning, and it focuses on developing neural networks. I think I look at neural networks as an interconnection of like multiple wires information is where information is shared and passed amongst them. Yes, so I feel like that's what makes up a neural network. Then in our real-time translator, we've been using supervised and unsupervised learning techniques, but these have, like any other thing, these have their loopholes and their shortcomings. So for supervised learning, you need too much data to train the model. And then for unsupervised learning, there is sometimes bias towards particular data. Then there is no basis for comparison. You have no starting point for comparing the data, basically. And then all this is going to also cause generalized data. So the methods, the term paper comprises looking into detection, recognition, and then how it's important and the extent to which AI can solve this problem. So we've been using observation and interview methods. So for observation, you basically have a checklist which contains the usability indicators, for example, the accuracy. And then for interviews, the researcher conducts interviews after the user tests. And then the user's testing sessions through a sign language assistant as an interpreter. So if we are to describe the data set that we used and what factors we considered when selecting this data set, basically we were looking at how relevant is the data set to what we are trying to do. Like, is it in line with sign language translation? Is it in line with sign language recognition? Then we were looking at the size. We didn't want something too big, but neither did we want something too small. Then we also checked the quality. This is basically the images, how clear are they, how precise are they, and many other things. Then the characteristics that an AI model is likely to exploit when it's looking at sign language detection is basically the shape of your hand. Like, if I'm trying to say L, it can't be like this. My hand has to be facing upwards. So if I do this, that's something completely different. Then the movement of the hand and the fingers, how are you changing? So the L, all the rest of the fingers should be down. And these two one should be pointing up and another should be pointing that side, right, if you're using your left hand. Then this other should be down. Then the background and lighting. Now, for example, if my background was black and I did this, would it still be L? Yeah, so those are the key characteristics which a model exploits. So selection and optimization, deep learning, SVM, straightforward, then the multi-layer perception. I mean, yeah, a straightforward machine learning approach known as the k-nearest neighbor uses the classes of data of the data's closest neighbors to categorize it. So for k-learning, it's going to look for what is the data closest to. If you have like so many circles in one area, then you have a triangle, but it's close to all those many circles and you're trying to categorize it. Basically, the model will categorize that as a circle. So the result of the discussion, to evaluate how the performance of our model, we were using confusion matrix, which is basically accuracy, precision, recall, and F1 score. These were discussed in our earlier presentations, I think presentation 1. So for more information about those, you can visit that. But yeah, and also sensitivity. So image, our future works, images don't necessarily provide sufficient information about the sign gestures. So people would prefer to use video representation rather than sign images, but videos need higher speed internet connections and larger storage spaces. So however adequate the video would be, it's a bit harder, and the technologies for processing these videos are still lacking a bit. So yeah, there's a link to the data set we used below, and then a link to the Python source code. So yes, that's it. Thank you.